Can you give us a broad overview of the types of projects that fall under salmon recovery efforts and explain how civil and environmental engineers contribute to those initiatives?
You can go watershed scale, be involved in planning efforts that are going to improve water quality or improve managing the landscape. And you can get all the way down to something as specific and very common as a culvert replacement to improve passage into the watershed. As civil engineers, obviously, we're working on infrastructure projects. You could have a lot of overlap in any of those areas. And so whatever we can do to improve those projects, provide what is needed to deliver that project.
Did you know that removing a single dam might open up hundreds of miles of habitat for salmon? But sometimes a series of smaller, targeted projects can make an even bigger impact. In this episode, we're joined by Steve Seville, PE, Director of Salmon Recovery at Parametrics, who will discuss how civil engineers are playing a critical role in restoring salmon populations and their ecosystems. This episode unpacks what salmon recovery really means from an engineering perspective, how science is influencing project design, and the strategic decisions behind scaling restoration efforts, whether through dam removal or a network of localized solutions. If you're curious about applying engineering expertise to environmental challenges, this episode will deliver real insights and inspiration. Before we jump in, I wanted to tell you about our AEC PM Connect Event, where emerging and experienced leaders can learn about real-world strategies to drive performance, empower teams, and lead with purpose. Visit aecpmconnect.com and register today. I'd also like to recognize one of our sponsors for the event, Keen Wealth Advisors. Keen Wealth Advisors is a fiduciary investment advisory firm based in Overland Park, Kansas. They specialize in helping engineers structure retirement strategies and tax optimization systems. They also have a unique understanding of ownership structures of AEC firms, including ESOP, privately held companies, and publicly held companies. For more information on Keen Wealth service offerings or to find their long-running podcast, Keen on Retirement, along with Bill Keen's best-selling book entitled Keen on Retirement, Engineering the Second Half of Your Life, visit keenwealthadvisors.com. I'm your host, James Taylor, and this is the Civil Engineering Podcast, the industry's leading show for civil engineering professionals, ranked as the #1 civil engineering podcast by FeedSpot.
Transform your technical experts into impactful leaders with EMI's Engineering Leadership Accelerator. Tailored for AEC professionals, this program enhances communication, delegation, and decision-making skills. Flexible, interactive, and designed to fit your team's schedule. Elevate your team's leadership capabilities today. Visit engineeringmanagementinstitute.org and click on Corporate Training.
It's now time for our civil engineering conversation of the week with Steve Seville, PE, Director of Salmon Recovery at Parametrics. Steve, welcome to the Civil Engineering Podcast.
Thanks, James.
Steve, can you start off by sharing a little bit about yourself and what led you to specialize in salmon recovery as a civil engineer?
Sure. So let's see. If I go way back, native Californian, grew up in that state in the 70s and always had an affinity for the outdoors. That kind of led me to civil engineering ultimately as a career. I liked the coursework. I liked the opportunities that I had in the field. So really happy to have ended up here. I think it really came out of my career evolving in civil engineering. I had the opportunity to work on a lot of habitat recovery projects. Most of the drivers around that were related to aquatic species, salmon being a big one. And as I had the opportunity to be more involved in that, I saw that I could start to make a difference. And so I started to focus on salmon. As a backdrop to that, always fished with my dad as a kid. And so just had a close affinity to, the species.
That's awesome. I love hearing that. And I was excited to see you on here because it's definitely one of those niche areas, and hearing more about that is what I'm excited to hear about today. So can you give us a broad overview of the types of projects that fall under salmon recovery efforts and explain how civil and environmental engineers contribute to those initiatives?
Sure. I think that there's a whole range of potential projects you can get involved in that have a benefit to the species as a target anyway, and have a lot of other benefits to other values. But you can go watershed scale, be involved in planning efforts that are going to improve water quality or improve how we're managing the landscape. And you can get all the way down to something as specific and very common as a culvert replacement to improve passage into the watershed itself. As civil engineers, obviously, we're working on infrastructure projects. So you could have a lot of overlap in any of those areas. Easy ones are, where our roadways, where our bridges, where our pipelines, those are going to cross waterways. They're going to have potential impacts to the habitat. And so whatever we can do to improve those projects, provide what is needed to deliver that project for whoever you're working with or working with a client, a municipality, but also have the environment in mind while you're doing that.
Can you talk a little bit about the need and of why salmon recovery is so important?
Yeah. Well, specific to the Pacific Northwest and the inland Northwest where I'm located now, we're focused on the Pacific salmon and their recovery in each of the states along the West Coast, partners in Canada, and then considerations of the other nations that participate in salmon recovery or rely on the fishery in the Northern Pacific Ocean. So, what we're focused on is recognizing that there has been a change in the population. You can see that as if you're tracking the returns in specific watersheds where you may have interest in fishing, or specific watersheds where you may be propagating a fishery. Year over year, you can kind of look at the numbers as they've dropped and pick your favorite river and start to dig into the data, and you can recognize that there's definitely been an impact. The historic numbers that you hear about from old tales of walking on the backs of salmon. Those numbers don't really exist anymore. So, what can we do to improve that as we're working on any of the projects that we're working on in a particular watershed?
What do you think has been the main driver behind the change in the numbers?
Yeah, so I believe those numbers, they go back a couple of 100 years.
Yeah.
And so when you consider what we've done is we've developed the landscape, each little project has a potential component that it's contributing to the change in the watershed. So there has been, we can document significant increases in water temperature, delivery of sediment to a system that changes the substrate where the salmon are wanting to spawn and juveniles are wanting to rear. Just the time that it takes for a drop of water to get from the upper watershed out to the Pacific Ocean. We're using that water. We're using intakes and we have outfalls as each community is utilizing the water resource as it travels downstream in a watershed. We also have impoundments for hydropower and impoundments for agricultural purposes. That changes the flow of water, and really it's just the system that the species evolved in has changed rapidly as we've started to utilize the watershed. So they're not evolving at the rate that we've been able to make changes, and so they've responded accordingly, and we've done many things to try and help them out, but we're never really, nor is it probably possible to get back to that original condition. Yeah.
And that's why recovery is so important. So can you share some examples of these, whether it be a small or large scale projects, the salmon recovery projects that you've worked on or even observed, and how the scale of those projects influences the potential impact on salmon populations?
Sure. Well, specific to the work that I'm doing, there's a real push in the state of Washington to improve fish passage over a variety of stream roadway crossings and stream intersections. It's called the culvert injunction is probably the simplest way to describe it, where there's been a lawsuit to force the state to address the issue for all of the state-owned crossings in a particular area. It's not the entire state. It's just a portion around the Puget Sound primarily. The state's doing a great job of trying to implement as quickly as possible as many fish passage improvements everywhere where there's a state-owned facility that's crossing a creek. So there's a large group of people working on this. We assess how much passage potential has been restricted with the current crossing. And then there's some protocols to investigate how best to improve that. So civil engineers engage with, ecologists, geomorphologists, fish biologists, and participating agencies to figure out what would be the best potential solution that's feasible for that particular crossing. And the intent is to create a stream passage that has no restriction for passage capability for the fish. So there is a balance there.
Yeah.
You have to understand how the stream is going to respond when you place a new crossing on there, whether it be a larger culvert or a bridge. You're going to have stream hydraulics. You're going to have geomorphology components associated with that restored crossing. Thinking of it simply, you know, many of these culverts were potentially installed 50 years ago,
Mhm.
and they were designed based on hydraulics alone, and not the functioning capability of the stream. So we're trying to restore that, recognizing that we'll push it as far as we can, and we want this crossing to function into perpetuity. So you're really trying to forecast, what's the watershed going to be like for the lifespan of this crossing and the health of the stream. So there really is a balance there, because
Yeah.
you can drive costs up pretty
Right.
significantly. Yeah.
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 Yeah, and I guess it's one of those tough things of like, yeah, we have this data now that allows us to do a better job of predicting how the water flows, right? And these things that were, hey, we need to get from point A to point A to point B on this roadway or this passage, whatever it might be. All right, just put a thing, culvert over it, and the water will do what the water does, but not realizing the ecological impact or the biological impact to the fish. And it seems like you said, you're kind of going back to fix things that were probably not done wrong at the time, but we're now realizing that things need to be fixed.
Yeah, that's correct. So, these examples, you were asking kind of the scalability of projects. So a crossing itself could have by itself a pretty limited impact. It could just be a few hundred feet of stream that are repaired, restored, and it may just be, a small distance before you find another barrier similar to that one. And that needs to be corrected as well to get the entire watershed completed. But together, hundreds of these put together, and you can eventually restore a watershed.
Mhm.
Its passage, it's restored to the extent you can, its hydrology, and start to tackle other issues like water quality, land cover, shade, temperature. All of those things can benefit from the fish passage projects being put together as a program. Beyond that, kind of a larger scale approach to salmon recovery would be assessing the actual population of a particular salmon run that may have existed or could exist
Hmm.
in a particular watershed. So looking at the entire scale of the watershed, what's the value of the habitat that's there now? Is it connected? Can the fish get there? Can they get there, on their natural life cycle? Timing of that water flow, of that hydrology, are streams still staying, wet? Are they drying up? Is climate change a component of that? Is water use a component of that? All of those factors, you kind of put it together and say, well, if historically a watershed functioned in a particular manner, and now it has all of these influences on it, what's the capability of that to continue to support a salmon population? And how
Right.
large could that population be if everything, we're working correctly? And so figuring out what carrying capacity would be for a watershed, and then trying to fit that together with all of the programs that are in place on that particular watershed. Can you get the salmon to where they want to be? So that's where kind of looking at the dam situation, that can be
Yeah.
a pretty hot topic of, oh, we need to remove all the dams and restore passage. That would be great for salmon. A lot of the dams are in place for a variety of other reasons, and we can't
Right.
just remove all of them instantaneously. I think we can work on a path to get us there as a larger society and figure out what to do. But, we're not going to fix it in a decade.
And this isn't really unique to just the salmon population, right? I mean, this is fish across the board of, hey, wherever spawning's taking place or whatever it is. I mean, these are very similar things that you can take from the salmon piece and apply to other populations of fish.
Yeah. Yeah, it's always a trade-off. So as civil engineers, we've got something that we're dealing with on the landscape. It was designed for a purpose. We decided to implement it, whether that was decades prior to us getting involved in the profession or not, or it's something that we're maintaining because a city or a population of humans needs it. The only way to get full salmon recovery is to remove us from the landscape. And
Right.
That's probably not
Yeah.
going to happen. So how can we balance that, and how can we maximize the habitat for those species to coexist with us?
So you talk about this a little bit, but can you elaborate on how scientific studies and ecological research influence the design, prioritization, or even the long-term impacts of these recovery projects?
Sure. I would say there's two components to that. There are scientific studies that will say look at fish fitness capabilities. How fast can a fish swim? That's a common one. What's the velocity requirement when you're going through a culvert for an adult salmon to be able to migrate upstream? And that's been in place for a very long time, and pretty well understood. We're starting to take a deeper look at all life cycles of a particular species. So what would a juvenile require? A juvenile doesn't have the swim fitness capability of an adult. So lower velocities, it becomes more complex to think about the design. So those scientific studies about what are the capabilities of the target species that you're trying to improve situation for, how do you incorporate that into the design, and how far can you carry it? So I think, from my perspective, we're doing hydraulic studies. We run a hydraulic model. It's going to give you discrete answers about what the velocity would be over a variety of flows through the new opening that you're designing. And then how much of that cross-sectional component of the new structure is going to accommodate, the swimming speed of a particular life cycle of a fish. So what's the value of that? How often does that happen? When do those flood events occur? You start to get into the statistics. And so you apply your engineering to the ecological criteria and the capability of that target species. Beyond that, I think there's another side of it of taking a look at kind of a watershed scale health, or watershed scale, I would say, landscape capability. What do you have on the landscape? Maybe you've got significant agricultural components that are very important. How have they been managing the landscape relative to where are those agricultural fields in proximity to a stream? Is there still a riparian corridor? Do you have shade? Are you maximizing the land for the production, or are you maximizing the land for health and production? So taking a look at how much of a change would be required to the use of the landscape to benefit the stream, I think we're starting to get closer to that. Although I would admit most of the studies or recent attempts at trying to solve this problem still stay a little bit more focused on, hey, the problem is sediment delivery to a stream. We need to stop that. And, maybe that's a no-brainer, but how can you really implement that on the landscape, knowing that the agriculture community needs to maintain productivity? We all need to eat, So it always needs to get back to a balance. And I don't know that we're really approaching that point where the balance is an element of the study.
Interesting. Very, very interesting. Obviously, this has been going on for a number of years now, and just like anything in society, there's trends and innovations that occur. So, what current trends or innovations are reshaping how engineering professionals approach salmon recovery and habitat restoration?
That's a good question. I see it in our industry, the technology being applied is far superior to what was available to me early in my career. Models are very robust. The ability to look at a larger area in a hydraulic model and compute whatever result you're seeking, it's just amazing to me what we're able to pull off and have a clear understanding of what's going on in a watershed or a river system compared to the assumptions that we used to apply when computing power didn't exist. So I always balance that with, do you take your understanding of the system and apply your assumptions and get to an answer pretty quickly? Or do you run a very detailed model and get discrete answers on whatever part of the model domain you're interested in? And are those answers really different? So what I have seen is, like I said, a huge increase in the capability of technology, and it better informs some of our thought process. But at the end of the day, I'm not sure that we're always getting to a place that's necessarily better for what I would call the answer, whatever you're trying to solve in that particular moment in time in the design. I think we can have more certainty in what we are calculating, But I do think that it's really important for us to not lose sight of the fact that we have to consider the problem, solve the problem, and not just rely on the technology. So I think that that's
Yeah.
it's probably been going on for years. I would say my predecessors probably thought that when I had an HP calculator, they wondered why I wasn't using a slide rule.
Right.
Yeah, right.
And it's one of those things where, technology is great. Like you're saying, like, hey, it can do so much, but if it doesn't provide the value to the project, it's just another thing, right? And it can almost become more of a distraction than purpose driven. And when you can make that connection between technology and the project to make it purpose driven, that's where you
Mhm.
drive those results. And I think just like anything, you're being very specific with this, salmon recovery and habitat restoration, but just about anything out there, if you have a technology that's available to you but you're not applying it the right way, or you're not using other thought processes, it might not help you in the long run.
Yeah, that's it's kind of always back of mind for me that when we engage in a project, like what's the outcome that we're seeking, and how are we going to get there, and what are the tools that we're going to apply, and what benefit does that provide us, whether we're saving time or we're you know we're we're relying on our experiences on previous projects to inform processes or improve design protocols. I think that that's all important. When you ask specific about salmon recovery, which has been the focus of my career for the past several years, what I find really challenging is we as civil engineers get the opportunity to work on the landscape. So we're influencing a certain component of the life stage of salmon. So either we're assisting adults in their return to the watersheds where they spawned, or we're assisting juveniles in their ability to develop for that first year or so of their life cycle before they get to the ocean, and then they go off into the Pacific. That whole entire period where, let's just pick Chinook salmon and round it out. Anybody listening to the podcast that's the fish biologist will probably call me out on this, but let's say the Chinook juvenile makes it to the ocean at the mouth of the Columbia at Astoria and then swims off for 4 years. We're not having any influence at this point on what's happening to that fish the 4 or 5 years that it's in the Pacific, becoming an adult and growing to a certain size. There's multiple countries that are fishing in those waters. They have their own regulations. And then each of those countries is also probably running a hatchery program and making decisions to deliver a certain population of a certain species of one of the Pacific salmon out there. And then they all swim around and they fight for food. So if we make decisions to release a certain species like pink salmon, because they grow pretty aggressively and they're great for the fishery as far as, total pounds of salmon you might catch at the end. If we put too many of them out there, they might outcompete other species that are also trying to, grow, find fish, and return to their home waters. So we're making decisions that could influence the population dynamic in the Pacific. There are studies that are going on about that, and I think that we have a clearer understanding of what may be happening, but we don't have consensus on how do we manage that, and can we manage that across multiple nations. So it's pretty common to read or hear, well, the reason that the salmon aren't coming back in great numbers is because there's a warm water blob out in the Pacific. And that may be true, and I think it is true, but I don't think that contributed consistently to salmon populations dropping. I think there are many more inputs into that equation that we're not really ready to control yet.
A lot of different factors there to manage and deal with. When it comes to these projects, it seems like there's a lot of people that can be involved. So how do you typically collaborate with scientists, different agencies, or even local stakeholders throughout these projects?
Yeah, the common thing to state, which may seem obvious, but it's probably the most effective method, is to figure out what that group is going to be in and engage early and often. Understanding what all the stakeholders' concerns are for a particular project and have that, written down ahead of time before you start. It is very important to know where people's perspectives are. And those are individual perspectives from a stakeholder, point of view. And then we need to figure out what resources, scientists are going to
Mm-hmm.
be applied to the problem. So I would say most commonly, we as engineers get involved. Fluviogeomorphologists are a big component to this to understand how the stream is going to function over time and marrying that up with civil engineering practice. Fish biologists, obviously, ecologists. And for me, I think a real important component to bring to the table, which happens quite frequently, but not always, is who is your planner? You know,
Hmm.
who's going to be that I think that bridge to, I'll just use a municipality as
Sure.
an example. So we are doing a discrete project. It might be part of a capital improvements program, and they had a reason to put that on the docket. But what's it going to link to? So within the planning of that particular city or county, why is this going to matter? What's the next project that's associated with that? So they're not one-offs. I'd say most people are kind of headed in that direction, but it's not a known when you kick off the project. You probably want to ask, hey, we're doing this for a reason, but why is it, what's going to happen after this?
Right.
Yeah.
So, Steve, it's been good talking to you today. What's one final piece of advice that you can offer to civil engineers who want to contribute meaningfully to environmental restoration efforts?
Yeah, I get this question pretty frequently. So what I always tell people that are interested in this component is don't worry so much about your career. Your career is going to find its way. If you have a hobby or a passion or a volunteer membership group that you want to participate in, I think that that's where you're going to find the value. So invest your time in those extracurricular activities that have some tie back to what you really like to do at work. And that's where you're going to find the value, and it's just going to elevate, what you're able to do.
That's a great piece of advice. Thanks, Steve. To wrap up, we're going to transition into our civil engineering hot seat, where I will ask Steve a rapid round of questions that will give you a glimpse into the daily habits, influences, and insights that has helped shape his career. Let's jump into it. Now it's time for our CE hot seat segment of the week with Steve Seville. All right, Steve, you're officially in the civil engineering hot seat. Are you ready to go?
Yeah.
All right. Do you have any specific rituals that you practice every day? For example, do you have a specific morning ritual or lunchtime ritual? Things that you do on a daily basis that contribute to you being a successful professional?
I have coffee every morning. That's required. And I do try to read a chapter or so of whatever book I have on my table at home. That just kind of grounds me.
Speaking of books, what's one book that you recommend to engineers regularly, or just one book that you found to be extremely helpful in your professional and or personal development?
Most recently, I read a book titled Stronghold. It's a biography of the individual that leads the World Salmon Center, I think is the title. And what was great about that was the story, followed his life. And he started in the Pacific Northwest. He grew up around salmon, and it really spawned him to better understand what's going on worldwide. So he's tackled a much larger problem, which I find inspiring and also daunting at the same time. So reading that, it gave me some perspective on the work that I do. So if you're interested in salmon, I'd recommend picking up Stronghold and seeing how you fit into that equation.
Thinking back on your managers of the past, picture your favorite manager or managers. What was it that made them your favorite?
I was very lucky early in my career to have a really strong mentor, and what I appreciated was their ability to listen to my daily sagas, how I was struggling early in my career, providing kind of thoughtful but short snippets of advice to just help me manage whatever was out in front of me, and then encouraging me to push a little bit further, asking me, well, where do you want your career to go? This is what you probably ought to do to pursue that. So I don't know if they know that they influenced me that much, but I definitely was listening and it had an impact.
I've got one final question, and that is the critical civil engineering career elevator advice question. If you had to get into an elevator with a civil engineering student and had about 30 or 40 seconds with them, what career advice would you share with them?
My career advice is pretty consistent, and that is to not focus specifically on your career. Your career is going to find its way. You've completed the training, you've done the coursework, you headed off in this direction. So, what are those other elements in your life that are going to define how you navigate that? And I think you get that through volunteer efforts, engaging in your community, tying your hobby or your outdoor activities, whatever it might be, into your daily work routine. And that's where you're going to be able to be more successful, because work's not going to be separated. It's going to be part of your life.
I love it. Steve, thank you so much for joining me today. Where can our listeners connect with you?
You can reach me at Parametrics. My work address would be the easiest place to get a hold of me. So it's just Seville, Seville at parametrics.com.
All right. Thanks so much, Steve.
Thanks, James.
Please remember you can find the show notes for this episode at civilengineeringpodcast.com. There you'll find the summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during the episode. Until next time, I wish you the best in all your civil engineering endeavors.